In this video, we'll be learning how to solve basic radical equations, and then we'll be learning how to solve equations that contain fractional exponents. So before we begin solving these, we need to know what they actually are. So a radical equation is an equation that contains radicals and variables. Now radicals are just considered roots. So we're going to be solving things like, the square root of x plus 2 equals 6. Or the cubed root of, 2x minus 4 plus 3 equals 8. Things that contain both roots and variables. Now the step we're going to go through as we solve radical equations is we're going to first isolate the radical on one side of the equation. So this is kind of similar to when we had powers in an equation where we got the power by itself and then undid the power. We're going to isolate the root or the radical first in these. Then we're going to undo the radical by using our knowledge of powers. So we know that roots and powers undo each other. We're going to be using that to help us solve equations that contain radicals so we can undo those radicals. And then once we've undone the radical, we're going to solve the equation and check our answer. So let's take a look at this first example here. We notice that we have a radical equation because we have a root and we have a variable, and we know that our first step is to isolate the root or the radical on one side of the equation. I notice that the root is being multiplied by 2, so I'm going to start by dividing both sides by 2 so that I can get my radical by itself. So here I'm going to be left with the square root of x plus 1 is equal to 4 divided by 2 is 2. So now I've got that radical isolated on one side of the equation. Now what I'm going to do next is I'm going to undo my radical. So I'm going to undo my radical by using a power. We know that this is really a power of 1/2. So to undo a root of 2, which is a power of 1/2, we're going to take the power of 2 to each side. So a power of 2 undoes that square root. So what we're left with on the left-hand side is x plus 1, and on the right-hand side, we're left with 4. Now from here, we're going to get our x value alone by solving. So we're going to subtract 1 on each side, and we find that x is equal to 3. So the next thing we're going to do is we're just going to check our answer to make sure that it works. We're going to take our x value and substitute it back into this original equation just to verify that it is correct. So here we're replacing x with 3. We then solve the root first, so we have 2 times the square root of 4. Well, the square root of 4 is 2, so we have 2 times 2, and that does in fact equal 4. So I know that my answer of 3 is in fact correct. Now if I move on to the next example over here, I can see that I have quite a bit going on here, but I know that my first step is to always isolate this root. So I'm going to isolate the root by adding 1 to each side first. So I have 5 cube root of 2x minus 9 is equal to, that's 15. Then I'm going to divide both sides by 15. So I have the cube root of 2x minus 9 is equal to 3. So my first step is to isolate the root. Then I undo the root by taking the power of each side. So here, because I have a root of 3, I'm going to cube each side of the equation. Cubing undoes a cubed root. So on the left-hand side here, I'm left with 2x minus 9 is equal to 3 cubed, which is 27. So now I simply need to solve the little equation I have left. I add 9 to each side, so I have 2x is equal to 36. I then divide both sides by 2, and I find x is equal to 18. So now I want to check my answer. So I'm going to take my value for x, and I'm going to plug it back into this original equation and just verify that it makes it true. So here I have 5 times the cube root of 2 times 18 minus 9, and then minus 1 on the outside is equal to 14. Well, if I focus here on the cubed root first, 2 times 18 is 36. 36 minus 9 leaves me with the cube root of 27. Cube root of 27 is 3, so I really have 5 times 3 minus 1. 5 times 3 is 15 minus 1, which I know does in fact equal 14. So I'm going to end up with 14 is equal to 14, which tells me that my answer is in fact x equals 18. So next we're going to look at how we solve an equation that contains a fractional exponent. So we're going to be solving things that look like, 2x to the power of 3 over 2 is equal to 8. So we're looking for equations that contain fractional exponents. And we're going to go through pretty much the same process. So here we're going to isolate the fractional exponent on one side of the equation first. So there should be the word exponent in there. Once we isolate it, we're then going to undo the fractional exponent by taking the reciprocal of that as a power. So what I mean by that is if we have something like 2x to the power of 3 over 2, what we're going to do on each side is we're going to take the reciprocal of that, and we're going to do to the power of 2 over 3 on each side. Now we're going to do that because this is our powers to powers rule, and if we have 3 over 2 times 2 over 3, that becomes 6 over 6, which is a power of 1. So it essentially undoes that fractional exponent. So we'll be using the reciprocal to help us out. And then once we've undone the fractional exponent, we're going to solve the equation that we have left. So let's take a look at two examples. Remember, to start, we're always going to get this piece with our fractional exponent by itself. So we're going to start by subtracting 4 on each side. So we end up with 3 times 3x minus 5 to the power of 1/5 is equal to 3. We then divide both sides by 3, and we're left with 3x minus 5 to the power of 1/5 is equal to 1. Now, from here, in order to undo that power of 1/5, we take the reciprocal, which is 5 over 1, or just 5, and we're going to take the 5th power of each side of the equation. And as we do that, these become 1 together, so we're just left with x minus 5 on the left, and then 1 times itself 5 times is equal to 1. So now we just need to solve the little equation we have left. We add 5 to each side, so we have 3x is equal to 6. Divide by 3, and we find an x value that is equal to 2. So now we're just going to run through and double check our answer, but we have our x value that we think is going to make our equation true. So if we take this value and substitute it in, so we have 3 times 2 minus 5 to the power of 1/5 plus 4 is equal to 7. Well, if I focus on what's inside of the parentheses right here, 3 times 2 is 6. 6 minus 5 is 1. So this is really 3 times 1 to the power of 1/5 plus 4. I know that to the power of 1/5 is really the 5th root. The 5th root of 1 is just 1. This is really 3 times 1 plus 4. So I end up with 7 equals 7, which is true. So my answer of x equals 2 is the value that will make my equation true. Now if I look at my second example here, again, I need to focus on getting my fractional exponent piece by itself. So I start by adding 8 on both sides. As I do that, I end up with 24. Then I divide by 3. So I have x plus 3 to the power of 3/4 is equal to 8. Now, in order to undo that fractional exponent, I'm going to take the reciprocal. So the reciprocal is going to be 4 over 3. So I'm going to take the reciprocal of each side. Now, on the left-hand side, I'm left with just x plus 3. On the right-hand side, I'm going to have to do a little bit of work here. I know that this becomes the 3rd root of 8 to the power of 4 if I use what I know about fractional exponents. The 3rd root of 8 is 2, so this is really 2 to the 4th, which is 16. So now what I'm going to do is I'm going to solve the equation for x. I'm going to subtract 3 from each side, and I find that x is equal to 13. Now I want to verify that my answer is true. So I'm going to substitute it back into my original equation. So I have 3 times, that's 13, plus 3 to the power of 3/4 minus 8. And I want to make sure that's equal to 16. Well, 3 and 13 added together is 16. So this is really 16 to the power of 3/4. So that becomes the 4th root of 16 raised to the power of 3. Well, the 4th root of 16 is 2. 2 raised to the power of 3 is 8. So I have 3 times 8 minus 8, which becomes 24 minus 8, which is 16. So I can see there that my answer of x equals 13 is in fact correct.